Today we're going to look at surface areas of pyramids and cones. It's going to be kind of similar to what we did with prisms and cylinders, except that in a pyramid there's only going to be one base. You don't have a top and a bottom, there's just the one base, and the sides are not rectangles. Instead, they're going to be triangles. You can see in this picture that in a pyramid, the faces, the lateral faces are all triangles. There's a couple different measurements that we use in pyramids. One of them is the height of the pyramid, and that height is measured as a perpendicular coming out of the vertex of your pyramid. But also, we talk about slant height, which is the height down the face of the pyramid, and it would come from the vertex perpendicular to the side down here. Let's practice drawing to begin with. Same deal applies, like when it says a square pyramid, you're not really drawing a square. It's more of a parallelogram or a rhombus. And then instead of drawing straight vertical lines, you're going to pick a spot to be the vertex of this pyramid, and you draw everything to that spot. And there's your square pyramid. A triangular pyramid just needs to have a triangle base. And again, don't get caught up on that happen to be a perfect triangle. It doesn't, because we're going to look at it from a different angle. And there would be an example of a triangular pyramid. Let's use the net of a pyramid to see if we can come up with a formula. In a pyramid, you're going to have faces that are all triangles. So this right here shows that there's 4 triangles. And I'm going to find the area of that triangle and then take it times however many sides my base has. This particular example has a square base, so I'm going to have 4 triangles. All right, to do surface area, I'm going to find the area of these triangles, and then I'm going to add in 1 base, because a pyramid only has 1 base. If you look at what this is, remember we laid this out flat, so this slant height right here is really this height right here. So when I find the area of this triangle, I'm going to have 1/2 base times height. So 1/2 base is the side length. Height is your slant height. So this here is how you would find the area of that triangle. Now, you have to take that times how many there are. So however many sides there are, we usually call that n. But if you think about it, if I were to take that times n also, let's look at what is n times s always going to get you. The number of sides times the side length. That's perimeter again. So the ns piece is your perimeter. So I'm going to write a surface area formula. It's 1/2 the perimeter, and then times the slant height, so I'll use a cursive L for slant height, and then I have to add in whatever my base is, but there's only 1, so I put 1 capital B there. There's our formula for surface area of pyramids and cones. On this problem, I've got a hexagonal pyramid, and so I'm using my typical pyramid formula, and I'm going to start filling in what I can. So the surface area is equal to 1/2 the perimeter, that's the perimeter of the base of the hexagon. So the side length is 6 here, times 6 sides, so the perimeter would be 36. And then they were nice enough to give me the slant height. They're showing that in the picture down the side here. Slant height is 9, plus area of the base. All right, this is a hexagon, so that's a 1/2 AP formula. So I have to find the apothem, and I have to find the perimeter. So I have SA equals, let's go ahead and we can multiply this stuff together. 1/2 of 36 is 18. And then take that times 9, and I get 162 for this first part, the lateral area. Now when I add in the base, it's going to be 1/2. Don't know the apothem, I'm going to come back, but the perimeter we said was 36. Now I have to figure out what that apothem is, and I'm going to go ahead and redraw their hexagon, because they have it drawn and drew the apothem in right here, but this is a terrible picture to try to decide what you're doing unless you really remember, because this is skewed funny. It doesn't look like a regular hexagon. because it's drawn sort of at an angle. So I'm going to draw us a regular looking hexagon. Okay, and if you drop the apothem and then your radius, you create a 30, 60, 90 triangle, and that apothem is your long leg. Now if this whole side is 6, then my short leg is 3, and my long leg, or my apothem, is 3 root 3. And that is what I'll put in right here, 3 root 3. Doesn't really say what to round to or anything, so I'll go ahead and just round to the nearest tenth, I guess. I have a 162 plus. Now I'm going to multiply this all together. So in my calculator, I'm going to type 0.5 times 3 times the square root of 3, close that parenthesis, times 36. And all of that gets me a decimal of 93.53. I'm going to just push plus 162. And there I have it, 255, and I'll round to the 10th, 0.5 inches squared. On this example, they weren't nice enough to give me a picture, so let's see if we can draw it and figure out the surface area. A square pyramid, all right, square pyramid. Remember, you don't really draw it so it looks like a square, it's more of a parallelogram. Okay, has base edges of 5. Okay, so every side is 5. Slant height is 3 meters. The slant height is coming down the face over here. It's down this face. That slant height is 3 centimeters. What's the surface area of the pyramid? Okay, well, I'm going to have to know the area of the base. The base is a square with all sides 5. Okay, that's not too bad. I think I can do that. All right, so here, I'm just going to jump into surface area then. Surface area equals 1/2 PL plus 1 base. The perimeter of the base. Each side is 5. There's 4 sides. Perimeter would be 20. Slant height, they gave us 3. Plus the area of the base, this is just a square. I would just do base times height. 5 times 5 is 25. All right, I think we can do this one in our head. No calculator needed. Half of 20 is 10, times 3 is 30, and 30 plus 25 is 55 meters squared. All right, let's do another one of these hexagonal ones. They're a little trickier. It says find the slant height first, then find the surface area. What is the lateral area of the hexagonal pyramid at the right? Okay, it says lateral. Let's scribble that out. I'm going to go ahead and find surface area because it asks for that. But in order to do that, we have to find the slant height. Let's look at all this information they gave us. 36 feet. Okay, that seems big, but here we go. That's the side length right here. So we know a side. And if you look over here, you're coming from the center and you're coming in here and you're hitting the side. That looks like it's the apothem in that hexagon. It comes in here perpendicular to that side. And then the 42, that's the height of the pyramid, but it's not the slant height, and the formula says use the slant height. Hopefully you can see this. Sometimes you just got to have, that right brain, left brain thing where you can visualize things. But what's going on here is that you have a right triangle. This height coming out, and then right here going straight across that apothem, and then the slant height coming down the side over here. Okay, that's a right triangle. And I know 2 of those sides. In that right triangle, I know this is 18 root 3, and I know this is 42. I'm going to do Pythagorean Theorem, and that's going to find this slant height for me here. So 42 squared plus 18 root 3 squared equals C squared. Now, I'm actually going to probably do the 18 root 3 first. So in my calculator, I'm going to do 18 times the square root of 3 and press enter. And then you should have just a squared button, just like an x squared. So if you hit your x squared button, it'll say, hey, take the answer and square it. If you don't have a squared button, then you're going to have to take that number and take it times itself. I end up at 972 for that. So just this part is 972. 42 squared is 1764. Let's add those together and square root it. All right, this did not come out quite as nice. I have a 52.3, and that is the slant height. So that would go right there. But ultimately, that's your slant height right there. Okay. The other thing that we're going to have to know to find the surface area is the area of the base. So let's work on area of the base. Okay. That's equal to 1/2 AP. So 1/2. The apothem they gave us, that was the 18 root 3. The perimeter is just all the sides, which each side is 36, times 6. And you get 216 for your perimeter. Let's multiply that stuff together. I have the area of the base to be a grand total of 3,367.1. Okay, let's fill it all in. The surface area is equal to 1/2. The perimeter of the base, we found that earlier. The perimeter of the base was right here. We said it was 216. That's the 36 times 6. The L is your slant height. That's what we did the Pythagorean Theorem to find. Plus the area of the base, that's what we just found over here, the 3,367.1. Notice that that's being added, so that's a little bit different. So I'm going to type this in my calculator left to right. I'm going to go 0.5 times 216 times 52.3 plus 3,367.1. And my total surface area then for this figure is 9,015.5 feet squared. All right, well, let's keep at it. This one is a square pyramid, and it says find the slant height first and then go find your surface area. So I'm going to let you try this one on your own. Go find the slant height like we did last time, and then you can do your surface area formula. This one should be easier because the base is a square, and that's easier to find the area of than a hexagon. Take a minute to pause the video, and I want you to work through this one on your own. All right, I hope you got what I got. If you did not, take a minute to pause the video and look at my work to see where that came from. Now, we're going to kind of move on past the plugging and chugging through that formula, and we're going to kind of work backwards through a formula. They've given me a couple measurements on a square pyramid, and I'm looking for the missing ones. Okay, so on a square pyramid, the surface area formula would be, let's see, 1/2 PL plus 1 base. Okay, in this, I'm going to draw a picture here so you can see what's going on. Given two measurements of a square pyramid, find the missing ones. What would be missing in this formula? The surface area I already know is 39. They gave that to me. 1/2. They did not give me the perimeter here. But if each side is 3, you could figure out your perimeter. You'd have a 12. So they ultimately gave me the perimeter. Okay, slant height, I don't know that I have slant height, so I'm going to leave an L there. Plus area of the base. Again, they didn't straight up tell it to me, but if I know the two sides are 3, 3 times 3 is 9. What's missing then is the L. Let's solve for L. This is 39. Half of 12 is 6L plus 9. Subtract the 9 to the other side. So 30 is equal to 6L. Divide by 6. L is equal to 5. Now your units on that, that's not an area that you found. You just find a length, so it's just 5 inches for that length. Okay, let's try one more time. This time they gave me the height, and they gave me the slant height. I feel like they're going to probably be looking for the surface area then, because that's the thing that I don't know. I'm going to use my same picture. Let me get rid of these 3's. I don't know. Okay, I feel like I don't know very much here. What I know is the actual height is 8. And then draw that apothem over. And then the slant height down the side, because I know the slant height is 10. Could we figure this out then? Because that's going to drop perpendicular. We could do the Pythagorean Theorem and find that missing piece. So let's do a quick 8 squared plus x squared equals 10 squared. That's a 100 minus a 64. That actually comes out nice. That's 36, which happens to be a perfect square. So what we found is that this piece here is 6, which means the full length across would have to be 12. If you look at your formula, we don't know surface area, 1/2. The perimeter, now that I know that this is 12, I could find perimeter. Slant height I know was 10. Area of the base I can find since I have the side length. So in this one, we're looking for surface area. That's what's missing. Surface area equals 1/2. The perimeter. Each side is 12, so I've got 4 sides. 12 times 4 is 48. The L, the slant height, that's 10. Plus the area of the base. That's base times height, or length times width. 12 times 12, 144. So then I'm left with half of 48 is 24 times 10 is 240. Let's add those up, and you get 384 for your surface area, meters squared. All right, thanks for sticking with me. I know this one's a long lesson here. A cone is the last thing, and it works just like the pyramid. It's just that we have special formulas for circle stuff. You still have a slant height. It's just down the side of the cone. You have an altitude or a height. That's a perpendicular measurement. You've got a circular base. And, of course, you have a vertex up here, a radius, those kinds of things. This is find the surface area in terms of pi. All right, so it looks like we're not going to necessarily use our calculator for evaluating that pi. Surface area, 1/2 PL plus B. 1/2, the perimeter. The perimeter on a circle is ultimately the circumference. So that's going to be times 2 pi r, and r is 15. So your perimeter is just circumference, times your slant height. Well, they gave us the slant height over there, the 25 would be your slant height, plus the area of the base. Okay, area of a circle is pi r squared, so I'm going to write pi times 15 squared. Now, I don't want to really just jump in and type this in my calculator because I don't want to get that pi in there, but I could at least just do the number stuff. I could do the 0.5 times the 2 times the 15 times the 25. But I have to stop there because of the plus sign. So I've got 375 pi. Plus, over here, 15 squared is just 225. So that's 225. pi. Add the 225 to the 375, and you end up at 600. My surface area on this is 600 pi centimeters squared. Okay, that's all I have for you. Hope this helps.